All right, welcome to The Explainer. Today we're going to tackle something that kind of messes with our heads, especially if you love sci-fi movies. We're talking about why the most insane, powerful events in the universe, like stars exploding or whole galaxies crashing into each other, happen in total, complete silence.
So let's start with a classic thought experiment. If a star explodes with the power of billions of nuclear bombs, but there's no one around to hear it, does it actually make a sound? Well, the scientific answer? It's a hard no. And to figure out why, we first have to get back to basics and understand what sound really is.
Okay, so before we can understand the silence of space, we've got to look at how sound works right here on Earth. Look, sound isn't some kind of magic force. It's a physical thing. It's a vibration, a wave of energy that has to have something to travel through. We call that a medium, like the air, or water, or even the ground beneath your feet.
The best way to think about it? It's like a chain reaction, right? A line of dominoes. One thing vibrates, let's say my vocal cords, and that pushes the particles right next to it. Those particles then bump into the next ones, and so on and so on. It's this physical game of tag that travels all the way to your eardrum, which then registers it as sound.
And this right here, this is the whole key to the puzzle. Sound moves fastest through solid things because all those little particles, those dominoes, are packed super close together. It's easy for them to bump into each other. It's a bit slower in the air because they're more spread out. So, what happens when there are basically no particles at all? Well, the chain reaction just stops. The dominoes are way too far apart to ever touch each other.
All right, so now let's take this idea and head out into space. We always hear it's a vacuum, but that word can be a little misleading. Let's really dig into what that great emptiness actually is.
Yeah, this is probably the biggest misconception people have. Space isn't truly empty. It's not a big box of nothing. It's just that all the stuff in it, the atoms, the molecules, the dust, is spread out over these mind-bogglingly huge distances. Gravity did its job and clumped most of it together into things like stars and planets.
Okay, let's try to wrap our heads around this. Right where you are now, the air is just jam-packed with stuff. If you took a tiny little box, about the size of a sugar cube, you'd find roughly 10 quintillion molecules inside. That's a 10 with 18 zeros after it. It's a number so big, it's almost meaningless.
Now, let's take that same sugar cube and teleport it out into deep space between the stars. What's inside? Well, you might find a couple of atoms, maybe 5, maybe just 1. And if you go into the great voids between galaxies, maybe none at all. The difference is just staggering.
I love this analogy because it just hits the nail on the head. Imagine a packed stadium, thousands of people doing the wave. That's how sound travels in our air. Now, imagine that same giant stadium, but with only one person sitting in it. Try starting a wave now. It's impossible, right? There's just nobody else to pass the energy to. That's space. Any vibration just fizzles out instantly.
And this is exactly why all those amazing space battles you see in the movies with the roaring engines and the pew-pew of lasers, scientifically, they'd be dead silent. Just silent light shows. A star exploding with the light of a billion suns, total silence. 2 giant asteroids smashing into each other at thousands of miles per hour, you'd see a spectacular flash of light and hear absolutely nothing.
Okay, so this brings up a really interesting question. If space is so silent, what's it actually like for the astronauts who go there? Are they just floating around in total silence? Well, not quite.
You'd think it would be silent, but actually, an astronaut's personal experience is anything but. Their spacesuit is its own little world, and it's a pretty noisy one. Remember, it's filled with air, so sound travels just fine in there. They're hearing the constant hum of fans circulating their air, the buzz of pumps for their life support, not to mention the sound of their own breathing echoing right inside their helmet.
But, and this is the wild part, just inches away on the other side of that helmet visor is the most perfect, profound silence you can imagine. It's so silent that if an astronaut could take off their helmet and scream at the top of their lungs, they wouldn't hear a thing themselves. There's nothing to carry the sound from their mouth to their own ears. Crazy, right?
So if the universe is silent, how do scientists listen to it? How do we get those cool, spooky sounds of space from NASA? Well, they have a really clever trick up their sleeve called sonification. Basically, they take data from things that can travel through space, like radio waves or light, and they translate that data into sound. They're turning information our eyes can see into something our ears can hear.
And this is a super important point to remember.
When you hear those sounds online, you're not listening to a microphone recording from a spaceship. It's a translation. Think of it like a scientist taking a bunch of data that looks like a squiggly line on a graph and turning it into a piece of music. It lets our ears pick up on patterns that our eyes might miss.
But wait a minute, is space always 100% silent? Are there any loopholes, any weird corners of the universe where sound can exist? The answer is, yeah, kinda, but it's not what you think.
So in certain places, like inside gigantic clouds of gas and dust called nebulae, the particles are just dense enough for sound waves to technically travel. The catch? The gas is still so thin that the sound would be incredibly faint and slow. More interestingly, in huge clusters of galaxies, there's super hot gas that carries these massive pressure waves, which are a form of sound. In fact, astronomers found a note coming from a black hole in the Perseus cluster. But it's a B-flat that's about 57 octaves below middle C, millions of times too low for any human to ever hear.
Okay, so we've established that space is silent, but this isn't just a cool piece of trivia. This silence is actually a fundamental feature of the universe, and believe it or not, it's incredibly important for science.
You can almost think of the silence as a gift, because there's no sound bouncing around, there's no noise to interfere with our sensitive instruments. Our radio telescopes can pick up the absolute faintest signals from the very edges of the observable universe. It's like having a perfectly quiet, clear canvas that allows us to see and listen to the cosmos with incredible clarity.
So if there's one thing to take away from all this, it's this. Space isn't silent because nothing is happening. Oh no, it's full of the most violent, energetic events imaginable. It's silent because the emptiness itself, the medium, just can't carry sound. And you know what? That really makes you appreciate just how special our noisy, vibrant, particle-packed atmosphere here on Earth truly is.
And it really makes you wonder, doesn't it? We've already learned how to listen to the universe using light and radio and even gravitational waves. What else is the cosmos trying to tell us in total silence? And what new senses will we have to invent to finally hear it?